Gravitational force between any two bodies can be calculated with the help of the mass of those bodies and distance between them. And this formula is used for the calculation m1 m2 masses of those two bodies, and d means distance between them, and g is gravitational constant, f is gravitational force. But today I want to talk about the distance. Sometimes we are confused about the distance. Let's say two bodies are separated by certain distance. We are always taking distance from center to center because gravitational force is concentrated towards the center of the body. That's why we have to take center to center distance. Now sometimes we are confused. If there is earth and a body is lying on its surface, then the distance between them seems to be zero. This is not correct. Actually, the gravitational force between earth and that body exists. It means there is distance, and distance should be taken from center of the earth to the center of the body like this. From the center of the earth to the surface of the earth, the distance is radius of the earth, and from the surface of the earth to the center of the body is the radius of the body. But in comparison with the radius of the body, the radius of the earth is very huge. That's why while calculating the gravitational force between earth and a body lying on its surface, radius of the earth should be taken as the distance between them. But sometimes the story may be different. Let's say two bodies are touching each other, and all of we know that they attract each other because they have mass, and this attraction force is called gravitational force. But what is the distance between them? Again, the distance is from center of first body to the center of second body, and this is equal to radius of the first body and plus radius of the second body. It becomes the distance between them from center to center. That's why in this case, sum of the radius of two bodies is the distance between them. This may be the confusion for the student. That's why I'm going to focus this. If the bodies are distinctly separated, there is no confusion center to center distance. But if there is a huge body like earth and a body lying on its surface, then radius of the earth should be taken as distance between them. And if two bodies are touching each other, then the radius of the first plus the radius of the second should be taken as the distance between them. Today I am going to present a numerical problem related to this third case. Look at this. There are two bodies and some other values are also given, and the numerical problem is study the given diagram and calculate the gravitational force between these spherical masses. If it is so, then we have to write first given. In the diagram, what is given? First object is mass is taken as m1 100 kg. Second object is mass is taken as m2 and it is 200 kilogram. And another information is distance. Why I wrote 5 meter plus 7 meter equal to 12 meter? Because distance between them is the sum of the radius of first and second spherical body, and diameter of second body is 14 meter. That's why its radius is 7. It is tricky here. 7 plus 5 becomes 12 meter is the distance between them, center to center distance. And gravitational constant, if it is not given, we'll write ourselves 6.67 into 10 power minus 11 Newton meter square by kg square. Now the question is gravitational force F equal to question mark. Now we are using the same formula, F equal to G m1 m2 by d square, and value of G is 6.67 into 10 power minus 11 into m1 is 100 kg and m2 is 200 kg, and the distance between them is 12 meter. That's why d square means 12 square. Now 6.67 into 200 into 100 becomes 20,000, and then 10 to the power minus 11. In denominator, 12 into 12 is 144. 12 is square. Now we are going to multiply the 6.67 and 20,000 with each other, it is 133400 and remaining 10 to the power minus 11 written, and denominator 144, and this number of numerator should be divided by 144 because number interacts with number, and the result is 926.388, and 10 to the power minus 11 remains same. Now we have to change the position of decimal. Normally we put this decimal point after one digit. It means it has to be shifted from this position to this position. I mean to say after one digit. So decimal point is shifted 2 digit left hand side, then the number should be multiplied by 100, and 100 means 10 square. So I am writing 9.26388 into 10 square into 10 to the power minus 11. While writing answer, normally we take 2 digit after the decimal point. That's why after this 6 we have 388, and 3 is less than 5. That's why we can ignore these 3 digits, and that's why 9.26 into 10 to the power minus 11 plus 2 becomes 9.26 into 10 to the power minus 9 Newton approximately, because some of the digits are removed. So I am writing here approximately. In the answer we have to write Newton. When we get answer, then it will be better to write one sentence for the answer. Therefore the gravitational force between them is 9.26 into 10 to the power minus 9 Newton approximately. Okay, this way we can solve the numerical problem related to tricky distance. Okay, this much for today.